Hello viewers, this is Wagada Ronald taking you through today's tutorial on how to find the resultant of a force of a system of forces acting at a point. So we shall start by learning how resolving is done. So the process of finding force components of a given force is known as resolving. The two components must be perpendicular to each other. So usually we use horizontal and vertical. So the angle between this and this will be 90. That's what we mean by the word perpendicular. So suppose a force F is represented by OA. This is force F represented by OA as shown in the figure below. Its components along OX and OY can be got by first dropping a perpendicular AB onto X. So from A, you draw a perpendicular to meet B, to meet X at B. This is what we have done, perpendicular to meet X at B. So extracting out triangle AOB, we shall get a right angle triangle. If this is theta, then it means that this will be the opposite, this will be the adjacent, this will be the hypotenuse. Remember, cos is adjacent over hypotenuse. So we shall say cos theta is equal to OB over OA. But we know OA is F. So OB over F. Making OB the subject, we shall get OB equal to F cos theta. Come to sine. Sine is opposite over hypotenuse. So this will be AB over OA. Making AB the subject, we shall get F sine theta. Now this F sine theta and this F cos theta are the components of this force, where this is the horizontal component of B and AB is the vertical component of the force. In other words, you can either draw this or this. They all have the same effect. In vector form, which you shall be using, F in vector form will be the same as the horizontal component, which is F cos theta, and the vertical component, which is F sine theta. Remember, the angle must lie on the horizontal. So the first step to do is to get the angle to the horizontal. That's when this formula holds. So the resultant of a given number of forces, for example from F1, F2, F3, Fn, is given by adding all the vector components. So the horizontal, I think, you can see it is plus or minus Fi cos theta. Fi meaning I can be 1, 2, 3 up to n. So here you can put F1, F2, F3 and so on. Plus means it is going to the right horizontally, and negative minus means it is going to the left horizontally. Also same to the vertical. Positive means it's going upwards vertically, and negative means it is going downwards vertically. And remember, it is sine theta, horizontal is cos. So theta is the angle to the horizontal. Always note that it has to be the angle to the horizontal. So we are going to do a certain problem. A particle is acted on by forces of 5 newtons, 20, 25 and 30 newtons as shown in the diagram below. So these are the forces 5, 20, 25, 30 with the corresponding directions, and they want us to find the magnitude and direction of the resultant force acting on the particle. If F is the resultant force, the first step to do is to convert these forces in vector form. We shall start one by one. So for the 5 Newton, it is entirely horizontal, meaning all the 5 is horizontal, vertical component is 0. For 25, I think you can see the angle to the horizontal is 70, so the horizontal will be 25 cos 70, vertical will be 25 sine 70, which is that. For the 30 Newton, it is horizontal is going this side, meaning it will be negative 30 cos 50, vertical is going upwards, meaning it will be positive 30 sine 50, which is that. Then for 20, horizontal is going to the left, meaning it will be negative 20 cos 60. Vertically it is going downwards, meaning it will be negative 20 sine 60, which is that we have got. So when you use the calculator, you add all these ones component by component. So we shall start with the first horizontal components. Add 5 to 25 cos 70 to negative 30 cos 50 to negative 20 cos 60. You'll come up with negative 15.7331. Do the same for the vertical. 0 plus this plus this plus this will give you 29.1531 newtons. But remember, they want magnitude and direction. So this negative horizontal means it's going to the left. Then positive vertical means it is going upwards. Now line joining the start to the end denotes the resultant force, which is F. So since this is the right angle triangle, we can use Pythagoras theory to come up with our magnitude, which is 33.1275. Then the direction, this is opposite, this is adjacent, so you can use tan theta being equal to 29.1531 divided by 15.7331. We'll come up with 61.6455. So that will be the direction. Then you can conclude that the magnitude of the resultant is 33.1275 newtons in the direction 61.6455 above the negative horizontal. Thank you for watching. I remain Ronald Walgada. Please subscribe to my channel, Rowa e-learning platform. Thank you.